everyone, welcome back to SAT Math Question of the Day. Here's our question of the day. Please give it a shot, pause the video, come back, and we will try it here. Okay, so you have f of x is 5 to the x power, and g of x is x squared plus 1. What is the value of g of f of 1 minus 2? So there may be a fancy way to do this, but it may make sense just to do it as straight arrow. You would first have to evaluate.
So I want to show you how.
You want to do it? Okay, go ahead, Seth.
Yeah,
you take over. Go ahead.
You need to figure out what f of 1 is.
Yes, you do.
Okay. Yeah, so let's do that. Let's see, I'm in red. So I use what's written on the question. I write f of 1 equals 5 raised to the 1th power, which is 5.
Okay.
Now, this 5 is the value that's over here.
Yep.
And so the value on which g is applied is 5 minus 2, which is known as 3.
Yep.
So then I need to calculate g of 3.
Yep.
So I put mine over here. And I substitute 3 for the variable of g into the formula, then evaluate the formula, and we get 9 plus 1, which is also known as 10.
Yeah, so that's right. So that's just a straight arrow approach to doing the problem.
Yeah.
But in terms of notation, sometimes it's, if we really have to discuss it, the notation f of 1 means evaluate f of x, which is a function 5 to the x, when x is equal to 1. That's all it means.
Yeah.
That's all it means. It doesn't mean f multiplied by 1 or anything weird like that. That's what it means. And this is called function notation. And this is a composite function, because first you have to do one step, then you get the answer, and then you apply function notation again.
Yeah.
Very straightforward.
It's the composite of 3 functions.
Yep.
F is one function. The function that subtracts 2 is the second function.
Yep.
And g is the third function.
Right. Okay, so I think we're done. I mean, this is just function notation and applying composition of functions. And just following the rules. Just do exactly what it says to do. And there doesn't seem to be any fancy shortcut or brilliant shortcut or brilliant pattern here.
Well, I predict that the explanation his explanation will show us a long-winded calculation, and what I want to convey to the audience is that when you solve the problem on the SAT, it's a good idea to shorten the writing steps,
right,
and use your eyes plus the pencil,
right,
to write in onto the paper.
Right.
Well, you're not using paper. That's a pain. Write in.
Like you have scrap paper.
To write in the values that are involved rather than write everything.
Right. So Seth did write everything. So let's model that here.
No. Well, I think when we look at the Khan Academy's explanation, we will see everything written out.
I know.
And we will see that the writing that we read from Khan is much longer,
right,
than the writing that you need to do to solve the problem.
Yeah, but Seth, you also did too much. This is how you probably would do it. You would see f of 1 is 5. You would cross this off and make a 5. You would maybe even in your head say that this is 3. You would look here, and in your head, you would do 9 plus 1. You would do 10, and you would get the answer.
Yeah.
This is how you would actually probably do it, not what Seth did. Let's go
Yeah,
back to what
yeah,
Seth did. I don't know. Can we see what Seth did? So this is
yeah.
that. You see, you wouldn't write all that.
No, I
You
wouldn't write.
wouldn't write all
Well,
that. You wouldn't write.
actually I was writing it to show how you would figure it out.
Right. But that's not how you would do it in
So
practice.
so that we would have a written cartoon that would show our audience what my eyes were doing.
Right, of course.
Okay.
But in practice, this is how you probably most people's sheets would probably look more like this. Okay, but that's really, really important. There's a difference between doing the problem the long way and doing the problem as basically as a competition, as a time with a time crunch. Okay,
Okay.
so let's go. Okay, good work. That's good. This is probably not a lot of steps, only 4. So it's standard stuff. Yeah, I mean, this is just standard stuff. This is exactly what Seth wrote out. So this is just,
Yeah.
exactly standard
Yeah.
stuff. So I think we're done.
Yeah.
Okay, today is Thursday, which means it is
Yeah.
Throwback Thursday. So we go back to a practice test, practice questions that the SAT gave me 20 years ago, before the 2016 test, when the test had questions that really weren't, that you wouldn't normally see in school. Now, after post 2016, the SAT sticks to questions you would see in school. So here's a question from a while ago. Back then, they had these strange questions where you would have to evaluate column A, evaluate column B, and decide which one is greater. And you would answer A, B, C, D.
Well, the trouble is that in these questions, many of these questions, such as the one here, it's impossible to evaluate column A.
Okay, let me see. Do they say anything about positive numbers?
What the goal is to figure out whether the values that might occur in column A, and of all the values that might occur in column B, is it always the case that a column A value is less than a column B value?
Right. Okay, so stop talking, just do the problem.
Okay, so, all right, so let's do the problem.
Go ahead. I think I'll leave this
so
one
we're
to you.
saying that, first, integers include negative numbers. They're whole numbers, including the
Hold on.
negative.
Wait. If you divide, Seth, if you divide negative, oops, I gotta put my annotation on. Sorry about that. If you divide negative 8 by 3, isn't the remainder a negative number?
Not necessarily.
No, wait. Okay, technically.
The remain. You might make a rule that the remainder is always positive. The divisor, the quotient is defined so that the remainder is positive or 0.
We should have to know that, but why don't you worry about the negative number when you're done?
Yeah.
Okay. First, do it assuming x is positive, x and y are positive. Okay, because that's probably what they intended. But anyway, go ahead.
Okay, so x is an integer, which when divided by 7, the remainder is 6.
Okay.
Now, what's the range of sizes of value? What's the ranges of x? What can x be? X, again, I'm thinking negative numbers too. X could be very, 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 very small.
It's 7x.
X could be simply 6. X could be very, 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 very big. And still divide by 7, the remainder 6. Right. Same thing for a different integer, y. And so since independently x could be big or small, and y could be big or small, you cannot predict any relationship between any inequality relationship between them.
Right.
And
yeah, that would make sense.
The answer is D.
That would make a lot of sense. So this question was almost easier than it looked.
Okay.
Right? Now, let me look. What about negative numbers?
No. Don't give me this. Don't write wrong things, please.
No, I'm saying
What
when an
the?
integer 7x is
Wait,
divided
wait,
by
wait,
7, the
where am I?
remainder is 6.
No, no, this
Wouldn't
is
that
you.
number be 7x
Hold
plus
on,
6?
hold on, hold on. What you wrote was nonsense.
That's true. It is nonsense. I agree.
So
I'm just
let's
playing with it.
cross it out.
I'm just playing with it.
Let's
Fine.
let's cross. Don't
You're right.
write nonsense.
That's right. It is
Where's
nonsense. I agree. Just playing with it. I'm just, doing
Yeah.
free thinking a little bit.
Yeah, no. Don't no. Let's say what you want to say is x being when it's divided by 7, the remainder of 6. That means x has the form 7 times n plus 6.
Okay, right. So I was getting close.
Or some
right.
n being an integer, which could be, all the like minus 10, minus 9, minus
right.
1.
Right.
0, 1,
yeah.
2,
so this
3.
is what I was thinking.
N is in elements of the integer set. So it's n that's multiplied by 7.
Right,
and it's
right.
Where n is a whole number
right.
to get x.
That's right.
This is junk. You put the x there. No,
I realize that's wrong.
Don't write false things.
Stop.
And then similarly, y equals 6 times another integer, m plus 5. And now n and m can range over all the integers.
Right, so they can be anything.
Cool. And so by making n and m range over the whole range of integers, you make the magnitudes of x and y also be very, very big or very, very small independently.
Right.
No way to predict a comparison of whether x and y are less than, less than, equal, or whatever.
Okay, so the answer is D. So we'll check the answer, but I must take offense as to what you said about not writing down nonsense. Seth, have you ever written stuff down doing a problem that later you said was nonsense?
Yes. But then when I show it to the public, if I realize it's nonsense, I tell them and I erase it.
You didn't give me a chance because you swooped in and said it was nonsense before I realized it was nonsense.
Yeah.
Okay.
Well, the thing is that it's a good idea to think before writing.
That's not the point of what we're doing. Those are other videos where they do everything cleanly and they show how to do the problem where they already know how to do the problem. I have no idea how to do the problem. I'm doing it like a real person.
The thing is, I have a PhD in mathematics,
That's
and
right.
that led me to the habit that the numbers like x have the form. The divisor multiplied by some integer plus the remainder.
Right. No. You're just completely
right.
correct.
It's not so there is that's the concept. Just remembering a formula. You take this formula and say, oh, maybe this thing should be an x in there.
It's
just
wrong.
Writing without thinking.
Okay, but that's okay when you're doing problems. That's called correcting. That's called thinking. That's called writing something down, critically deciding it's wrong and changing it. Yeah, I knew something was wrong about this. This did not make me feel comfortable. So you're saying that if it doesn't make me feel comfortable, I shouldn't write it at all.
Well, it made me feel absolute pain and horror.
Okay, well, it did not.
It made you feel uncomfortable, but it put me into pain. Okay. I felt a mental agony.
Right.
I got mad.
Okay. Well, okay. Let's see if the SAT people agree. Here's the book. They do not give an explanation in this book. That's the old days where they just told you the answer. So this is section 3, number 24. So let's go to the answer book. Sorry for the delay. Section 3, 24 is D. D. Yes, D. Okay, congratulations. So Okay, so who are we? Seth does. He mentioned it himself. PhD in math from MIT. He's a professor emeritus in computer science at SUNY Albany. I'm Seth's brother. I have a PhD in mechanical engineering. I take the more practical approach. Seth takes theoretical. Seth got upset when I make mistakes. That's okay. And we're here to show you how to approach SAT math questions. We do Throwback Thursday. This is a strange question. You won't see this on the modern tests. But we try to show different approaches on how to do a problem. The previous problem, there really is only one way to do it, in any practical way. And in terms of approach to studying for the Math SAT, go to Khan Academy, practice on their questions. They offer 2 courses, the non-digital and the digital course. Figure out which test you're going to take, talk to your guidance counselor, do the Khan Academy questions, and then, of course, actually take previous SAT math tests that are given by the College Board.
Okay. Well, this question
Okay.
is a rather boring question.
Yes, it is a rather boring.
Well, so let me leave our audience with a more interesting question that's based upon this question.
Okay, go ahead.
And instead of this kind of a question, let's have this. A, X and Y must be equal.
Okay.
B, X and Y can be equal. And C, X and Y cannot.
Right. Can never be equal.
Can never.
Okay. Okay.
Now that's a Chinese remainder theorem question.
Okay.
The Chinese remainder theorem says that the answer is B.
Oh, they can be equal for some X and Y. In other words, there is an X and Y for which X and Y are...
That they are numbers.
There are numbers.
There is a number called X and Y because X is let that number be, let X and Y be, both be the same number.
Right.
There is a number which when you divide by 7, you get 6, and you divide by 6, you get 5.
Okay. Okay.
Yeah.
Great. Okay, is it easy to find that number?
No.
No. Okay. Okay, so if you don't know the Chinese remainder theorem, you would have this would be a struggle. Wikipedia
is a great resource for math.
Right. Yeah. Yeah. The standards are
and that why is it so? It's because there are a bunch of people in the world who love math so much that they write up math. They write down what the math that they like into Wikipedia.
Yeah. 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 Shows the free exchange of information can lead to really positive results. Okay, so please like us, dislike us on our YouTube videos. Comments are encouraged because we like feedback. And if you have any SAT math questions, then please email them to us at satmathquestionoftheday@gmail.com. And we hope to see you tomorrow because we try to do this every day except on weekends. Chinese remainder theorem. Yes, if you're interested, go to Wikipedia and you can read all about it. Read all about it. Okay, I guess we're done for today, right?
Yeah.
Okay, take care, everyone. Have a good day.